When I look at enterprise today, I already know 80 to 90% of the time what the biggest, baddest vulnerabilities are that I'm going to find. And the reason is your methodology and your tooling. They don't consider them vulnerabilities. The attackers do. Hi, I'm Matthew Toussain, the founder of Open Security. We do penetration testing, vulnerability assessment, red team, incident response by day, but by night I'm an instructor and author with the SANS Institute, the author specifically of the SEC460 Enterprise and Cloud Threat and Vulnerability Assessment course. And so when we talk about enterprise vulnerabilities, they certainly have a market interest on my side. So what is that big number one vulnerability to rule all vulnerabilities? And it is, you guessed it, passwords. It's passwords. Yes, I know. Oh, gee whiz, you tuned in just to hear about passwords. Again, I get it, right? But the thing about it is that passwords are such an obvious problem that we look at it and we say, yep, that's an issue. Okay, moving on. But it's actually in our haste where we've made our number one and most critical error, because we realize that these are an issue. But we also don't realize that they're a solvable problem, that there is something that we can do about it. And the reason why this is very difficult for us to do is because we'll look at a bad password and say, hey, yo, come on, change that password, pick good passwords. Do we need to do IA training again? And unfortunately, this is just not a great way to go about getting better at passwords. Because we fail to realize here is that if we say, hey, yo, change your password, is that person going to select a better credential next time? Or is the vulnerability still going to exist? Are we actually patching, if you will, the issue? We need to understand why credentials get selected inside of our environment. This is critical because that why might give us an idea of what the real problem is. For example, consider your everyday average user. They have to select a password to log in. And if we're talking about the average enterprise, what we're talking about here is an 8-character long credential. Okay, could be better. And we're talking about some password policies. And these password policies are going to say something like complexity. Ooh, that's key. It's gonna say things like password rotation every 90 days. And it'll have something like password history in place that says that your password needs to not only be changed every 90 days and complex, but it also can't be any of your past 10. And I, as a user of the enterprise, you can tell, super corporate with a jacket, I, as a corporate user, need to be able to navigate my path through selecting a credential that meets all of these criteria and still allows me to get my work done. Because if I forget it, gotta get on the help desk phone line every other day, work ain't gonna be happening. And so what do? I, of course, as an intelligent corporate drone, invent myself a gimmick, a methodology for password selection. And I say, what changes every 90 days? And what changes every year? Does this give me entropy for ideal password selection? And the answer is yes, it does. It gives me really good methodology for password selection. For example, winter 2020, we're almost there. This is a great password to select. If anything, it's actually a little bit too strong. Winter, capital W, 20 for the year. And what we have, a perfect password. You got complexity, you've got the length, and it turns out in 90 days, something about that's going to change. But my password is still going to be critically good. And we look at this, we say, users are dumb, they're bad. But we're the problem. What we haven't invented is a password policy that is itself what we call a negative security control. That is to say, it doesn't only not provide benefit, it actively makes it worse. Because think about it from the office space perspective.
We need to talk about your flare.
Really? I have 15 pieces on.
Well, okay, 15 is the minimum. Okay?
Okay.
Now, you know, it's up to you whether or not you want to just do the bare minimum or, well, like Brian, for example, has 37 pieces of flare on today, okay? a terrific smile.
Okay, so you want me to wear more?
Look, Joanna,
Yeah.
people can get a cheeseburger anywhere.
How many pieces of flair do you need to wear? If the policy says 8, then it's 8. If we're not happy when they don't go with something better, then the policy is the problem. This is a password selection vulnerability due to negative security policies. Don't just believe me. Carnegie Mellon University has done studies on this that demonstrate a high correlation between strong, allegedly complex password policies and bad password selection. NCSC says don't do this. NIST says don't do this. Microsoft says don't do this. The freaking FTC says that these policies are bad. But all of our enterprises have them. Attackers know this, and they are fantastically good at identifying gimmick-based security, and they will exploit your environment over it. I was doing an incident response earlier this year, right before the pandemic, and I showed up, because incident response, you always get called on the phone on Friday night when they realize there's nothing that they can do except call help. Otherwise, work ain't happening next week. So, get on the plane Friday night, typical incident response, show up, first thing I do, quick vulnerability assessment. Why? Because I already know, 80-90% of the time. In this case, managed security service provider set up a user account called test3 with a password of password123. Made it a domain admin. The thing that astonished me the most was that this enterprise had this vulnerability. And let's make no mistake of it, this is a vulnerability. This enterprise had this vulnerability on their environment for 3 years. 3 years is the last time that account had a credential changed. It was password123 for domain admin for 3 years, and it took 3 years for an attacker to get in. That was the most astonishing part about that. And unfortunately, this is so common, and it is so very unfortunate. As vulnerability assessors, we are the custodians of our environment, looking at things like MSP setting credential, help desk having bad processes for credential selection, looking at admins who have a default credential that they are putting all over the place, maybe a default build of an operating system, manufacturers having default credentials, Cisco, and putting them on our environment. Are we auditing these things? And when we find these credentials, is our solution change the password? Or is our solution identify why a poor credential happened on our environment in the first place? Who put it there? Why was it there? Where is it? How long has it been around in our environment? If we can get answers to these questions, we can identify the underlying issues. But what's the CVSS score? Well, there isn't one. Because you see, our automated solutions, like our vulnerability scanners that we rely so heavily on, they are fundamentally flawed at discovering some of the biggest problems in our enterprises. They simply are. Because this is not what they do. They have no ability to identify the difference between a feature that was configured as designed and a feature that was poorly configured, like a password policy or a password that a user's actually picked. How can they know what is good enough for our risk tolerance? They can't. We need to calculate that. And that is what vulnerability assessment and SEC460 is all about. Now, I want to take a minute to share with you a quick lab from the actual class so you can get an idea of not only the content that we're talking towards, but also some of the hands-on opportunities for learning. This is a short one, but I think you'll find it's quite sweet.
In SEC460, we have a full enterprise virtualized environment for all the students to explore and learn as we go through vulnerability assessment, both in the enterprise and in the enterprise cloud. But in order to do this, there needs to be some meeting in the middle of learning material, book smarts, let's say, and hands-on learning opportunities to make certain that things stick, because we all learn in different fashions, but at the very end of the day, if you've done it, you can probably replicate that and do it again. And as a result, we have ourselves a lab workbook. We, in fact, have many labs in the class and a couple different modalities on how to explore them. For example, we've got this wiki that you see here. There's also a print workbook that you receive and a soft copy workbook as well. And as you can see, there are many labs here. Let's take a moment to look at this lab 1.3. We're going to do a bit of a brief overview, and this is a smaller lab as far as 460 goes, but it's a particularly interesting one for two reasons. First off, it's got a little bit of a cloud-esque appeal, but it's something that we often overlook. And one of the ways that this lab is particularly interesting to me is that this is a lab where we've had a student in the class itself. This was at Sands Fire 2019. And she was sitting in the front row, and she was doing the lab. And then when she finished the lab, she tried to perform the lab steps on her environment. And her company ran a banking software application. That's what they made. And so she ran it in her environment, and she found this exact vulnerability, which would be critical for them. And we're talking banking here. Credentials exposed on the internet directly, and they had no idea. So she stands up in the middle of the lab time and says, "Hey, thank you, great course. This is awesome. I gotta go. Bye." Come to realize after the fact, one of their developers had done exactly some of the issues that we'll see in this lab itself. So this lab is on open source intelligence gathering, or OSINT. And here we're looking at one specific source, though in the class we discuss many. But this specific source is GitHub. GitHub has been, it's not fair to call them responsible for many compromises, but it has certainly been the source of a lot of ire for many enterprises over the years. And that's because of what it is, what it does, and how it's used. So you create a quick GitHub account, and then with that account, we have the ability to perform search within GitHub. These searches can be very simple, or they can be a little bit more advanced. And here you see they've got an advanced search feature, which will allow us to create searches with certain search directives within them. So you might look up for the word, say, a password, let's say. And then we might be looking for it in a certain user account. And you see here it says user : osmosis. And the reason it does that is because of those search directives. And so these are all search directives right here, but the advanced search will automatically fill those in. So it's very, very simplistic and easy to use, but it is definitely something that we should search for. Because if we search for something as simple as password and Deloitte.com, we'll find out that there are thousands of entries related to that. And a quick caveat for everyone watching this. What you are seeing now and about to see more of are real credentials for real users, real passwords for a real organization, a fairly major one, Deloitte. In fact, the reason why we're looking at Deloitte is because one of our case studies in day one of the class is on Deloitte and their exposure via Azure AD and via uploads of code samples to GitHub very directly. And we can see that these passwords are often not necessarily the most strong. We also see additional exposures about things like internal IP address space, what that is actually related to, more passwords, port numbers that are open on different sites that are available. This is open source intelligence gathering, and so it's okay for us to look, but do not try to use any of these because they just might work. And if they do, we have moved beyond the gray area of security and straight into illegality. So do not use this unless you have permission to test. But as we can see, there is some very significant exposure that we identify immediately. And this isn't just theoretical. For Deloitte.com, this led to a major compromise of this organization. And at the time, Deloitte had been rated for 5 straight years as the #1 firm in information security consulting by Gartner. So if it affects them, if it affects a student in class who just happens to look for it for their enterprise as well, it may affect us as well too. Now, the way we have to kind of look at these things is a little bit more dynamic than just that. For example, what kind of software technology stack does our enterprise use? Let's say that we use something like Firebase as a database, right? Because that's what Firebase is. It's a real-time database by Google. And let's say that our front-end stack for that is React.js. We're just saying this for any of our given applications out there. Now, if we look at this here and we look that up, we'll see that there are a few tutorials on how to code in Firebase. I don't necessarily recommend going past the first three, but if we look at this, at these results, we're going to get some really interesting information. Information about how our developers probably made the application, because they probably followed this tutorial at some point. And if that tutorial is leading them astray, our environment will likely have the same vulnerabilities. And so if we are looking for things like database credentials, we could go for first off, we probably want to know what kind of file name these have, because one of our search directives in GitHub is file name. And so does this file name have to be firebase.js? No, it does not. But is it almost always firebase.js? Not only yes, but we can prove it. Let's do a search directive in GitHub. So it looks like we're seeing a lot of that file name. Now, in this tutorial, it's using API keys, Cloud Data Store, right? That's pretty typical. Now, what developers often are starting to realize is that passwords are important. Okay. Obviously, they're not always realizing that, as we just saw, but they're starting to get a little bit of a hang of this. I say a little bit. But what they often have completely overlooked are these API keys. And so, it looks like the API key here is named API key. Let's see if we can't find any. Because in this case, the credential isn't a password, it's a key, an API key. There we are. We look through our code samples here again. Let's see if we can't find any API keys. And there we go. We've seen some API keys. Now, there's some other things to recognize here too. Developers will often do this incorrectly. For example, here we see a API key that's being imported from a separate file. That is actually a good thing. This is how you're supposed to do it. But you're supposed to create a file called gitignore that tells it not to upload that special file when you sync. Oftentimes, developers will mess this up. And we can take a look at that. So it says it's importing this API key from a file called API key in the current directory. If we go to the top of the directory, we'll see that there is this gitignore file. Let's see if they're ignoring that API key. Interesting. Let's take a closer look then, shall we? And yep, it looks like they have successfully ignored that API key file. But there's one last thing to check. Did they always do this? GitHub also has history. And oftentimes, they'll have ignored the API key eventually after they figured it out. But they might not have done that early on. And so you might want to look through this history to see if that's actually the case. It says deploying with API keys. And it looks to be that this developer may have done it properly, which is fantastic. But generally speaking, during the time allotted for this lab, I'll be looking through and I will find 0 days in more than one application that have not done it properly. Here's another example of doing exactly that. But here they're using relative pathing. This is a very easy thing for a developer to mess up. Do you think they did it right in this case? Oh, they did not do it right. Notice here's a really common error that we see. So here's the API key, and it says removed API key. So that's a note that the developer put in. That means that this developer probably uploaded the API key on accident and then tried to remove it afterwards. In this case, they didn't actually even remove it properly. But if we were to go to the history would then reveal that. So this is exactly that issue I was talking about a moment ago. And we will see these all the time. And this is exactly the issue that bank had. In fact, it wasn't actually an API key, it was a direct password, but it was a password that was in the history. And the developer had tried to remove it, but there we go. Here's the API key in the history as well. This is critically important because many of these applications are the thing that our enterprise stands upon. And it's not just API keys, it's not just passwords, it can be RSA keys, GPG keys, access credential. In the case of Deloitte, they uploaded their VPN keys in addition to many different passwords. This is a critically significant issue, and we need to be aware for it as vulnerability assessors, because we're not just focused on the internal enterprise anymore, but we also have to consider all of the external dependencies that our multifaceted enterprises contain today.
Thank you all again so much for joining me for this quick video with a real quick basic overlook of SEC460, what its goals are. With this class, we really hope to change what's going on in the industry because we are not winning just yet. However, we most assuredly can. It's all about dotting those I's, crossing our T's, covering our bases, dealing with the scale and uniqueness of our individual enterprises. Because once we start to control all of this data, we can also begin to take action on our enterprise and corporate risk. Stay tuned, and as always, happy hacking.